Hey everyone, welcome to the very first episode of the Manic Mech-E. I'm Michelle, a mechanical engineer with a passion for building cool stuff. If you're into 3D printing, robotics, programming, or just overall engineering, you're in the right place. Today, I'll be talking about my vision for an exoskeleton project I'll be starting from scratch. I'll also be talking about 3D printing basics, bringing my Ender 3 back to life, and the progress I've made in learning electronics. Like I said, I'm a mechanical engineer, but my experience is mostly in thermal design. So I'll be learning alongside with you. Stick around to learn more about my channel, my progress on my exoskeleton dream, and how you can start printing your own projects. So, who am I, and what's this channel all about? I'm a mechanical engineer by day, but my real passion is tinkering in my workshop. The Manic Mech-E is where I'll share my journey building DIY projects, focusing on 3D printing, robotics, and a big dream, a robotic exoskeleton to help people with lower extremity disabilities regain mobility. My goal? Build up multiple prototypes of the robotic exoskeleton by the end of the year, and hopefully grow this channel to 1,000 subscribers by then. I'll be sharing tutorials, time lapses, and tips along the way to inspire makers like you. Plus, I'm selling STL files, troubleshooting guides, and DIY courses on Gumroad to fund this project. You'll see me post every 1 to 2 weeks, so hit that subscribe button to follow along. Let's talk about the exoskeleton. I'm designing a lower leg prototype to assist people with lower extremity disabilities and help them regain mobility. Imagine an Iron Man type exoskeleton made of a lightweight frame that uses a MyoWare EMG sensor, which reads muscle signals and connects to an Arduino Uno. The Arduino processes the signals to control servo motors, which move the joints, helping with mobility. My vision is a budget-friendly open source design that makers can build at home. It's early days, but I'm aiming for a working prototype by late 2025. You'll see every step here: design, printing, coding, and testing. What have I been up to lately? It's been a wild ride getting my Ender 3 ready for this project. I first bought this printer in 2018 and used it for a while, but ended up leaving it in my garage for years, until I dusted it off this past month and finally got it printing again. I've run into all types of problems. The mainboard firmware somehow got corrupted in the past 7 years, and while I was troubleshooting this, I created an arc which must have shorted one of the components on the mainboard because it never worked. So I just bought a new one. I spent way too much time trying to reflash the firmware. So don't make the same mistake. If it's not working and you don't have the right instruments to test it with a reader, just, they're cheap enough, so replace it. If it works, then it means that was the part that was wrong. Also, when I shorted the power supply, it damaged some components, so I had to replace the power supply. Then I noticed one of the hot end fans wasn't working, and the cost for a new fan was similar to buying a direct drive, so I just went ahead and replaced the direct drive, which ran me about, I want to say, $35. More recently, I've started building simple electronic circuits to control a servo with a potentiometer. I've also started testing MyoWare EMG sensors, wiring them to my Arduino to read muscle signals. I had no success with this. So then I called my electrical engineering consultant, shout out to Il Giorgio, and he made a few recommendations. First, my connections should be soldered, and second, the system should be battery powered, since my MyoWare EMG sensors are extremely sensitive to noise that comes from powering it directly from the wall outlet. Finally, I'm starting to design the exoskeleton in CAD, and I'll start printing soon. These steps are laying the foundation for the exoskeleton, and I'll share more in the next videos. Now, let's get into 3D printing basics. First, setup. Make sure the frame bolts are tight, tighten the belts, and level the bed using the paper method, as you see on the screen before you. I use PETG for durability, so I set my nozzle to 240 degrees Celsius and the bed to between 80 and 90 degrees Celsius. I use the Cura slicer, and I've been using AI to determine my slicer settings. I highly suggest you do the same to save time. Living in the future is pretty sick, guys. Work smarter, not harder. Next, you want to load your filament. Slice a model like a 3D Benchy or some calibration STLs and start printing. Pro tip, watch the first layer to ensure it sticks. If it doesn't, stop the print, level the bed, and start over. If you can use some of these Elmer's glue sticks. They really work. Highly suggest them. If you're new to 3D printing, don't worry. We're living in the future, remember? You can always ask your favorite AI or drop a comment below with any questions, and I'll do my best to answer them. As you can see, you'll be generating a lot of waste in the beginning, which is why I'm building a trash can. Heavy air quotes. More like a frame to hold a trash bag. In reality, these are general parts that can be used for anything like making a 3D printer enclosure. And I designed them myself. You can grab these STL files from my Gumroad, which you can find the link in the description below. That's it for our first video. I'm actually stoked to be sharing this 3D printing and exoskeleton journey with you. Next up, I'll be sharing soldering tips, further troubleshooting the MyAware EMG sensors, and hopefully control some servos with them. Subscribe and hit the bell so you don't miss out. Check out my Gumroad for STLs and follow me on X and Instagram for updates. The links are in the description below. Do me a favor and comment what your 3D printing setup is like. Let's build something awesome together. I'll see you next week, and remember, be the change you want to see in the world. I'll also be talking about 3D printing basics. I'm stoked to share this 3D printing and I'll also be talking about 3D printing basics, reviving. It's alive! It's alive! Stick around to hear more about my channel, my exoskeleton dream, what I've been up to lately, and how you can start printing your own projects. Boom.